Practice exercise 14.1 split stack asks us to write a method called splitStack. It's going to be public splitStack, and it's going to take a stack of integers. So we'll just do stack, type integer, and we'll call it S. And it splits it into negatives and non-negatives. The numbers in the stack should be arranged. All of our negative numbers appear on the bottom of the stack, and all of the non-negatives appear on the top. Looks like we're going to return void. It also worked when I was testing it if you want to return an actual stack. Keep that in mind too, but we'll have it as void for this just to have some simplicity. So for something like this, we're allowed to use a single queue as auxiliary storage. That's another key thing. So before I get into how I'm going to do it, let's also make this queue. It's going to be of type integer, of course. It's going to be called a queue. I'll set it equal to a new linked list where our type in here is integer. So this is our queue and we have our stack. Now we need to manipulate these two things. So here's what I'm thinking. Here's what I propose that we do together for solving this. I propose that we want to put these stack values, the values in our stack, into our queue, right? We want to load everything up, but we want to keep a tally of how many negative values that we have. And once this is done, we can, once everything's in our queue, right, and everything's unsorted, we're going to start with it unsorted. From then, we can separate our negatives and our non-negatives. And the way we would do this is once we have everything in the queue, we're going to push the positive values back to our stack, and the negative values will just add back to our queue. We're going to remove it from the front and add it back to the queue. We're going to keep a tally of our negative numbers so that we know how many times that we can do this as well. So we're going to do int neg, and inside of here, we'll just set it equal to 0. This represents our negative numbers. And we're going to increment this. So we're going to go through our stack and add it into our queue right now. So while our stack is not empty, meaning we have an exclamation point, we'll have s dot is empty. We want to run this as long as it's not empty. And as long as it's not empty, let's check our current value. Int temp is equal to s dot pop. So this is going to store the current value. Remember, pop is taking it off our stack, and we're storing it inside of temp for now. We're going to say if temp is a negative number, so that means if temp is less than 0, we're going to want to increment our negative number. So we're going to do neg plus plus, and then no matter what, remember, we're going to add this to our queue. So we're going to do queue.add, we're going to pass in our temp. And we're going to do this until our stack is empty. Once our stack is empty, this is where our check comes in. We're going to want to run this while loop while we no longer have any negative numbers. Because remember, we're going to keep pushing our negative numbers to the back of our queue. And once all of our positive numbers are done, we are going to want to add the negative numbers, which would then shorten our queue. So while our neg is greater than 0 inside of here, make sure you have braces because a lot of code that's going to go in here. Not a lot, just a little bit. So inside of here, we're going to have if, and we want to check our current value. So there's a difference between peak and pop. And as a matter of fact, we can change this from a pop to a peak. So we don't even need this variable. A peak is where we can look at the current value without removing it from our stack or our queue. And I'll demonstrate that with this later on. But for here, we're going to use peak. So if queue.peak, that means we're going to look at the first value in our queue. Remember, a queue is first in, first out, while a stack is first in, last out. So if queue.peak is less than 0, this means it is negative. And if it is negative, we want to put it in the front of our queue, right? Or I'm sorry, we want to put it in the front of our stack. So we want to remove from our queue, push to our stack. So we're going to do s dot push, and we want to push the negative queue value. So we'll do queue dot remove, and then we're going to decrement our negative value because we have one less negative value inside of here. So that's going to be how that would work, like this. We are going to push our negative values to the stack. I think I said positive values earlier, can get a little bit confusing. So what I'm saying right now, as we go onto the video this is kind of law. So we're pushing the negative values to our stack. That means they're going to be at the bottom, which is what we want. Otherwise, we are going to want to add the positive values to the back of our queue. I think I said the opposite earlier, but I hope you get the point of it now that it's coded out right here. So otherwise, we are going to do q.add and then q.remove. So again, this is for the positive case. If the value is positive, we want to push it back into our queue. And we're going to do this until we run out of negative numbers, right? Then we know if we do this, right? This is going to show us that in our queue, all that's left is positive values. And if positive values are all that's left, we are just going to do a s.add, or s.push, sorry, because we're pushing to our stack. And then we're going to do q.remove. But we need to do this inside of a while loop so that we can do it while our queue is not empty. Because once it's empty, we don't need to do it anymore. So while our queue is not empty, we're just going to do this s.push. So we push to our stack, q.remove, and that will eventually empty out our queue. Hopefully that makes sense. If you have any questions, as always, leave them in the comments below the like button. We're going to run our test. It'll pass 6 out of 6. So that's how I'd go about looking at this problem, solving for it. And that's 14.1 split stack.